So the next thing we're going to talk about is what we call composite functions. It's basically when we take two functions and put them together to make one. And that one function is composed of two separate functions. So we're going to look at how can I use composite functions to evaluate numerical to put a number. How can I take a number and put it into two different functions versus how can I actually create a composite function and then use that composite function to do my evaluating. So with part one, we're just going to look at how do I take a number and how do I use two separate functions to come up with a final answer to manipulate that number. So let's look at these kind of review type problems. So suppose I have a simple function. I have this linear function here, f of x equals 3x plus 4. What if I were asked to find f of 2? What does that tell me to do? Well, it tells me to go to my function f. Okay, I'm there. Remember, f of x is the same thing as y. Since this is the same thing as y, I cannot plug anything in for this x, which is a big mistake that I see people want to do. But instead, once it tells me to go to my function f, everything over here, every time I see a variable, I'm going to put 2 in its place, giving me f of 2 equals 3 times 2 plus 4, which is 6 plus 4, or 10 for my final answer. I am not trying to get f by itself. F of 2 is read my function's value when 2 is plugged in, so there's no reason to get rid of this 2. Same thing if I looked at the next one. Suppose I had g of x equal 2x squared minus 3x plus 1. What does this mean? It means go to my function g, and every time I see a variable, put negative 3 in for that variable. So g of negative 3 will give me 2 times negative 3 squared minus 3 times negative 3 plus 1, which is 2 times 9 plus 9 plus 1. 18 plus 9 plus 1 gives me 28 for my final answer. Again, I'm not trying to get g by itself. So we've done that before. We've seen that before. So moving away from that, let's talk about actual composite functions. So again, a composite function of g with f is written as, it's often written like this, or f circle g. A lot of times people mispronounce it and say, what does fog mean, especially when it's written the other way. But what this stands for is g following f of x. So the second one here, this kind of more, I guess, inside function, for lack of a better word, is going to be my first function, and then I take my g function. I will always first rewrite it like this. That way it's clearer to see. If I start from the inside, if you think about order of operations, I start inside of those parentheses and work my way out. So we're going to look at, I believe I have 3 examples. It looks like I have the first example written twice, so I apologize for that. So we'll just do it once. So looking at my first example, so I have f of x equals x cubed, g of x equals x squared plus 7. I'm trying to find first g following f of 2. Well, that is the same thing as saying g of f of 2. So according to order of operations, I'm going to start on my innermost parentheses and I'm going to figure out what f of 2 is. So I'm going to go ahead and I'm going to leave the g alone. And in order to figure out what f of 2 is, I'm going to take 2, and in my f function, every time I see a variable, I'm going to put 2 in that place. So instead of having x cubed, I'm going to have 2 cubed. Well, I know that 2 cubed is 8, so this then gives me g of 8. And now what does that tell me to do? That means go to my function g, and every time I see a variable, I'm going to put 8 in that variable's place, giving me 8 squared plus 7. Well, 64 plus 7 is 71. So g of f of 2 is equal to 71. What if I'm asked to find g of f of negative 1. Well, notice on this first one, the very first thing I did is I rewrote it in a notation that involved parentheses. I already have it in a notation that involves parentheses, so I'm going to go ahead and start on my innermost parentheses. That tells me to go to my function f and plug negative 1 in for every variable, giving me g of negative 1 cubed. Well, I know negative 1 cubed is negative 1 times negative 1, which is 1, times negative 1, which is negative 1, giving me g of negative 1. So what does that tell me to do? It tells me go to my function g, and every time I see a variable, put negative 1 in for it. Everything else stays the same, giving me negative 1 squared plus 7. Negative 1 times negative 1 is 1. Plus 7 is 8. So g of f of negative 1 is equal to 8. Moving on to, example 2, I'm going to use the same function. Now I'm going to find, so I just found, because one of the questions I get asked all the time is, does it really matter what function I put it into first? So let's look. So the first one I did g of f of negative 1, where I started on the inside, I started with f. Notice now I have f of g of negative 1, so I'm going to start on the inside with g. This then gives me f of, I'm now going to plug negative 1 in for g. So I'm going to go to g, and I'm going to have negative 1 squared plus 7. Well, that gives me f of, well, negative 1 squared is 1. 1 plus 7 is 8. That tells me go to my function f. Every time I see a variable, plug an 8 in. Well, I only have one variable, 8 cubed, which is, sorry, I should have had this punched out already, 512. So notice that I do not get the same answer as I did when I started with my function f, as opposed to starting with my function g. Looking at the third and suppose f of x is 3x minus 7. G of x is x squared minus 2x plus 3. So the first thing I'm going to find is g of f of 4, or g following f of 4. So I'm going to leave the g, f4, putting it in a notation with parentheses. That's a little bit more familiar with me because that's order of operations. That tells me to go to my function f and plug a 4 in every time I see a variable. So the g will stay, and f of 4 becomes 3 times 4 plus, minus 7. So I'm going to go ahead and I'm going to still leave the g. 3 times 4 is 12. 12 minus 7 is 5. This now tells me to go to my function g, and every time I see a variable, plug 5 in, giving me 5 squared minus 2 times 5 plus 3. Well, 5 squared is 25 minus 10 plus 3. 25 minus 10 is 15, plus 3 is 18. That was part A. Part B tells me to find f of g of 4. So again, looking at that idea of, does it really matter? So I'm going to go ahead and I'm going to leave the f, and this time I'm going to go to my function g, and every time I see a variable in g, I'm going to plug in 4, giving me 4 squared minus 2 times 4 plus 3. Well, what does that give me? The f is going to stay. So 4 squared is, I guess I can write it out. So I'll write it out. 4 squared is 16 minus, that's not supposed to be negative 16. I don't know how that extra mark got there. Minus 8 plus 3, giving me f of 16 minus 8 is 8. 8 plus 3 is 11. So what does that tell me to do? That tells me to go to my function f and plug 11 in for each variable. Well, 3 times 11 minus 7. 33 minus 7 gives me 26. So that's what we're going to do composite functions. So I'm taking a number and I'm putting it into one function and then another. So my answer is an answer of basically two functions composed together because I'm working with both functions. So now that we've looked at what it looks like to compose or to take a number and put it into two separate functions and get those answers, and we can kind of compare those answers, I want you to go back to that problem that we looked at, that you looked at in the last video. I've now broken it down a little bit more for you. Can you re-look at what you did before? So if you did not know how to work this and you guessed, try and rework it. So try to go through, can you write a function to represent the price if you just take the discount? Can you write a function that would represent taking that coupon off? Can you find some kind of a composition function to find what the cost would be if the discount is applied first? So what would you get if the discount was applied and then the percent off was applied? What would you get if the discount was applied? Oh, I'm sorry, I mixed these up. So what would you get here if the discount was applied and then the coupon? And on this one, what would you get if the coupon was applied and then the discount? So please do that for class tomorrow for your ending piece of this video.